It's day 15 of Maker Advent, and what does that mean? Well, it means it's day 8 of the Pi Hut Maker Advent calendar. So I have the box in my hand. Let's open it. Ooh, lots of stuff packed in today. Okay, I can see. Ooh, a temperature sensor. DHT11? TMP? No, this is something a little bit different. More jumper wires, always handy. A resistor. Now I could be clever and say that I know that this is a such and such by looking at the colour code, and I can, because I've written a guide on that, but it's a bit dark today so I can't. But I've looked ahead in the instructions, it's a 4.7k resistor. But what's the actual sensor that we've got today? It's this thing. Get in shot. There you go. This is a DS18B20 compatible, it says in the guide. DS18B20 is a one-wire sensor, so it sends one-wire serial connections. It really needs two, but one wire is the name of it. With this, we can send temperature data via a one-wire interface to the Pico and get pretty accurate readings. We can also put this into water because it is heat shrinked and it's all watertight. So let's do something cool with this. Let's have a look at the instructions for it. So there we go, Maker Advent Calendar Day 8, tracking temps. Okay, so in the box we have custom waterproof temperature sensor with male jumper wires, a 1 times 4.7k resistor, and 3 male to male jumper wires. Yep, that's what we've got in the box. So it's given us a brief explanation of what one wire is. Now it's actually DS18B20, it's one of my favourite temperature sensors because it just works. It's simple and you can put it in all sorts. It came with CamJam Kit 2, I do believe, which I mentioned in the previous video. That's a good kit if you can get hold of it. They are out of stock now. I don't know if they're going to make them anymore, but hopefully they will. So we're going to reuse the circuit, the base circuit, which is the buzzer LEDs, and we will have a second breadboard, which we've got dotted on my desk somewhere, to connect up the DS18B20. The white wire is ground. The middle wire connects to GPIO 26. We do like that GPIO pin. And the red wire goes to 3.3 volts. You'll notice though, the resistor goes between the yellow wire and the red wire. That's our pull-up resistor. Its sole job is to keep that data pin pulled high so that it's always on. It never drops down to 0, so there's no connection issues, it just keeps going. So we're going to wire that into the Pico, and we've got some simple code which will let us just read temperature sensors. Now luckily the DS18B20 library is now part of MicroPython for the Raspberry Pi Pico, so it's ready to go, which is great. So with that in mind, let's start building, let's start coding. One moment please. Okay, we are back, we have built the project, and what have we got? Well, we have our DS18B20 connected to GPIO 26. It's got 3 wires connecting the sensor to the Pico, power, ground and the data pin. The data pin is pulled high using a 4.7 kilo ohm resistor to the 3.3 volt pin, and we've got some code to get it all working. So let's just quickly go into Phony, and we'll do as we do every time, go through how it all works. We've got some new imports this time. Also we're importing a little differently. Previously we've done imports line by line, but you can do it with a comma between each one. So in this case we're importing one wire, that's the protocol to connect, a serial connection, DS18X20, so that's the 18B20 library to read the temperature sensor, and then time. These could have been written as import one wire, import DS18X20, then import time, so each separate line. But in this case all in one, absolutely fine. Next line from machine import pin. That's our GPIO access, so we can connect to the pins and do some cool stuff. And next one, sensor pin, an object. This object's sole job is to make a physical connection between our code and the actual sensor that we've got connected up. Our sensor's on pin 26 and it's an input. Another object, sensor, this says, hey MicroPython, we've got a DS18B20 sensor and it's connected to the Pico. You cool with that? That's all it's doing, and it uses one wire to connect and says, oh yeah, look on pin 26 for it, that's your sensor pin. So reusing that object we just created. Then it'll do a scan for the sensor. So the DS18Me20, each one of them has unique ROM code. There are loads of clones out there. Trust me, I own a few. If you have more than one DS18Me20 connected to a machine, so Raspberry Pi, a Pico, microbit, whatever, you need to make sure that they each have different ROM codes. If they are the same one, it will just go error. If you've got different ROM codes, you can have dozens connected and get temperature readings from everywhere. Okay, our old friend while true. So while true, do this forever. So convert the sensor reading into centigrade. We then sleep for 2 seconds. It gives it time just to settle down before we take a reading. Just like the PIR sensor, we've got to give it time before it takes a reading. Then a for loop. For ROM in ROMs. Remember I mentioned about the ROMs, you can have unique ROMs. If we have more than one device connected, we'd have to scan through all the ROMs and get readings from each ROM and then print them off. In our case, we've got one sensor. That's it. It doesn't matter. But we're going to use it anyway. It's good practice. We then say, okay, print the sensor reading from temperature sensor, DS18Me20, on the ROM. And then at the end of it, just append degrees C. Then sleep for 5 seconds and take us all the way back to line 14. Now let's do it all again. So I'm going to run this code now. 14 degrees C. It's not the warmest day today. It's -7 outside, I think. But could we change that reading? Yes, we could. So if I put this in my hand, it'll probably go up a little bit to start with. 19. A lot actually. 19.9375 degrees C. What happens if I put it into this cunningly placed glass of hot water? 36 C. It's getting warmer. I boiled the kettle for a cuppa about 20 minutes ago, and this is the cooled down water. So it's 40 degrees now. So that's cool. So let's get some kitchen roll to wipe that off so I don't electrocute myself. But that's going to slowly decay in temperature as it goes back to ambient temperature. So you can see this DS18Me20 is a really cool sensor. Connected with a Pico, you've got a cheap little temperature monitoring system. So what have we got on the board? What can we use? Temp sensor, a buzzer, and we've got lights. So I happen to know that day 8, project 2 is using the LEDs. The same imports as before, one wire, DS18X20, machine import pin, LEDs on the same pin, DS18Me20 pin, sensor pin's the same setup, the same scan, while true, sleep for 5 seconds between readings, scan for the ROM of the DS18Me20, convert the temp, sleep for a second, take a reading, print the reading, and then a conditional. If the temperature is less than or equal to 18 degrees, red on, the rest are off. So if the reading is between 18 and 22, what would be comfortable, that's amber. That turns on. If the reading is greater than or equal to 22, green is on. That's nice and warm. Let's give this a go. So it should start off, give it 5 seconds. Green, 25.81. Why is that? Because temperature sensor is still going down to an ambient temperature. It's still quite hot. How can we cool it down? Well, let's try something. This may take some time. So right now I'm taking the temperature of banana for scale. We're getting down to the magic 22. Bingo. We're now less than 22 degrees. You can see the amber lights turned on. And to get it down to 18, I fear may take about a fortnight. So there's day 8, example 2 done. Let's have a look at day 8, example 3. One moment, please. Okay, example 3. This one uses the buzzer as well. Nice bit of fun. So let's have a look quickly at the code. Same imports once again, but we've also got something special. PWM is back for one more day. Pulse width modulation. That's there to control the buzzer frequency. So by turning the pin rapidly on and off, remember the annoying kid with the light switch, we're controlling the tone of the buzzer. LEDs are back. Buzzer's on pin 13 using PWM. Duty cycle, so how long is it on for? 0. We don't want it to make any noise to start with. Same sensor setup once again. We've done on the previous 2. And function. Alarm. our alarm function. Buzzer duty. So that's volume up, that's 10,000, that's loud. For loop for I in range 5. Do this 5 times. Set the frequency, so the pitch that we can hear, to 5,000. Turn on all the LEDs. Sleep for 0.2 of a second. Set it to a lower frequency, lower pitch. Turn off all the LEDs. Sleep for 0.2 of a second, so that creates the two-tone beep boop beep boop beep boop, and then the lights going on and off. After the 4 loops completed, we say duty 0 for the buzzer. We don't want it on. Then we say while true. Okay, do this forever. This is now the start of the main code. Wait for 5 seconds, get a reading. Check for a reading on the sensor, so 4 ROM in ROMs. Convert it. Wait a second. Get a temperature reading. Print it. If it's less than 20, call the alarm function. That's it. Now in the example on the Pi-Hot's website it says less than 18, but because I've been messing around with hot water, my temperature sensor is a little hotter than normal, so I set it to 20, should be good. Let's start the code, see what happens. It's going to wait for 5 seconds before we get a reading. It's 16C, it's cold, so let's get the temperature sensor, put it in the hot water. It's going to slowly go around and take a reading again. There you go. You'll notice now, if reading less than 20, do the alarm. But there's no else condition, so it doesn't got anything to do. It's just sat there going, what do I do? So we could add an else condition or an else if condition to say if temperature's over 30, make the red LED turn on and make it beep 3 times. Completely up to you. But yeah, there we are. Another day of the Pi-Hot's Maker Advent Calendar. And you know what? I'm liking it. I may have complained about the lack of Pico W, but there isn't one that's pre-soldered just yet, so let's benefit of the doubt for now. Hopefully next year we'll get a Pico W in there. But for basic electronic experiments, so with MicroPython, with sensors, with outputs, it really is good value. I mean, 40 quid, that's going to equate to what, about $45, $50? That's not bad at all. That's a good bit of fun in a box. And you're learning every day. Anyway, that's all for today. See you later.